Hey everyone, welcome back to the channel. Today we are diving into one of the most futuristic and fascinating topics in tech, that is quantum computing. Now, if you ever wondered how computers could get even smarter, faster, and more weird, you're in the right place. Quantum computing isn't just an upgrade of what we already have. It's a whole new world based on the laws of quantum physics. Let's explore how this sci fi sounding technology is actually becoming reality and what it means for us. First, let's understand the basic difference between classical and quantum computing. In classical computing, everything boils down to bits, which can be either 0 or 1. Simple, right? But in quantum computing, we use qubits, which can be both 0 and 1 at the same time, thanks to a phenomenon called superposition. And it doesn't stop there. Qubits can also be entangled, which means two qubits can be mysteriously connected. Changing one affects the other instantly. It sounds magical, but it's science. These two are core ideas. Superposition and entanglement are what give quantum computers their insane power. Okay, now you're probably thinking cool science stuff, but what can it actually do? Well, quantum computers can solve certain problems much faster than classical ones. Take Shor's algorithm. It can crack big encryption keys that would take classical computers years or even centuries to break. Or Grover's algorithm, which speeds up database search dramatically. This is what we call quantum speedup. In some areas like optimization, chemistry, cryptography, and even AI, quantum algorithms can revolutionize how fast and effectively we find answers. Hardware challenges and qubit stability. Sounds great, right? But building a quantum computer isn't as easy as building a PC. Quantum systems are extremely fragile. A tiny disturbance, which is heat, light, even vibration, can mess up calculations. So, quantum hardware must be kept at ultra cold temperatures close to absolute zero. There are several approaches like superconducting circuits, trapped ions, and topological qubits, but all face challenges like scalability, error correction, and cost. Imagine trying to balance a spinning top while a fan is blowing. That's kind of stabilizing is qubit like. Let's move on to the fun part. Where can quantum computing make a real difference? In pharmaceuticals, it can simulate molecules and proteins to find new drugs faster. In finance, it can optimize portfolios and detect fraud. In logistics, it can create super efficient routes for delivering systems. Even in climate modeling and material science, quantum computers can simulate systems too. And yes, it could even boost AI and machine learning models to the next level. But there's a flip side too, especially in cybersecurity. Quantum computers could break many of today's encryption algorithms like RSA and ECC. That's why the world is moving towards post quantum cryptography, designing algorithms that are quantum resistant. This is not just theoretical. Governments and tech companies are already racing to secure systems before quantum threats become real. It's like preparing a security upgrade before the hacker even built their tool. Who's leading the race in quantum computing? Well, it's a global competition. Companies like IBM, Google, Microsoft, and Intel are developing quantum processors. Startups like Rigidity and PSA Quantum are pushing creative solutions. Governments, including India, are funding national quantum missions to build talent and infrastructure. In 2019, Google announced it had achieved quantum supremacy, solving a problem that would take classical years thousands of years. Each year, we are hitting new milestones, higher qubit counts, error rates, and more powerful algorithms. So, what's next in the exciting journey? We are still in the early days, like the 1950s for classical computers. But the future holds hybrid systems where classical and quantum computers work together. We'll see growth in quantum cloud platforms, quantum networks, and even quantum internet. There's also a huge focus on building talent. So, if you are a student interested in science or tech, this is a great time to jump in. In the next 10 to 20 years, quantum tech could become a mainstream as cloud computing is today. To wrap it all up, quantum computing isn't just hype, it's happening. Yes, we have hurdles to cross from hardware to algorithms and then to policy, but the opportunities are endless in science, healthcare, and security, even everyday tech. This is time for students, researchers, developers, and innovators to get ready because the quantum era is coming and those who understand it will shape the future. Are you ready to be part of it? Okay, then until next time, keep learning, keep exploring, and let's build the future together. Bye, friends.